All right, I think we need to go on record here is what we need to do. Okay, so we watched the videos yesterday about the sharpening. And when you get to that project, I will actually take each and every one of you out and do a small demo on how to do it so that you can see it. So where we left off was B, sharpening.
Put that in parentheses.
Why should it be in parentheses? Sharpening. All right, and then we watched the videos. And then according to the videos and things, we have things you can modify / control when sharpening. Okay, what are the things that you control or what you want to, what you control? Give me some ideas.
Angle.
What? Yes, angle. Very good. There's only about 8 of them. Which angle?
All of them. Chisel edge angle.
Lip angle.
Drill point angle. Relief angle?
How about the included angle?
Oh, let's go with that.
Field angle.
What's the included angle? And you're thinking the same thing. What's the included angle? What is the included angle?
It's an angle you include in the drill bit.
It's this angle, which should be what for general purpose drill bits?
118.
118. You can control that by where the wheel is, how you address it to the wheel, right? Is there a time when I'd want it to be something other than 118?
Yeah, when
Yes.
you're doing hard steel, you want it to be 146.
Okay, good. You want it flattened out if you're doing something hard steel. What if I'm doing some plastic?
40 degrees.
How much?
90.
90. Or pointing. Okay, so we can do that. And I'm going to have just one other one. What is the other angle that is probably, I would say, even more critical? Very good. Relief.
Apparently not.
Relief angle, also called lip clearance. So either which way. I've heard it both ways. Drill bit speed and pressure. All right, so we all agreed that it probably is cheaper under most circumstances to simply buy a new drill bit. However, if you do learn to sharpen them, and there's been many times I've had a drill bit, it's just if it just gets a little bit dull or a little bit of damage, it's actually quite simple and fast if you know how to sharpen a drill bit, just to walk up and give it a couple little swipes and you're good to go. And it's not always actually that economical to run to the store to grab a new drill bit, so it can save you some money. But
It only makes sense if you have one like that size right there.
yes, because
Probably
those are
$100 bid.
expensive. But if you have 40s, you should already have 41's a whole handful of them. But so while that can be something we could argue about, one thing you can't argue about is drill bit speed and pressure is something you need to know. All right, so for soft metals, or soft materials, sorry, or soft, we'll go soft metals / materials. So what's a soft metal? That's kind of a little bit harder.
Copper.
Because what
Brass.
you guys are, brass. You guys are drilling aluminum. What kind of drill bits do you have?
2.
Something flew in front of me.
I saw it.
Okay, good. I'm glad somebody else saw it. All right.
General purpose?
General purpose for your aluminum. All right, so soft. We're going brass, something like that, bronze. For soft, let me see, where are we at? The included angle should be, let's say about, because it can vary. About how much? Okay, 90 degrees. That's 45 each side. Use a higher speed with, want to think high or low pressure?
Low pressure.
I'm gonna add that, very low pressure. If you're drilling plexiglass, which is something you do a lot as a mechanic, you put almost no pressure on it very, very little pressure, and you back up your work. You should always, actually, no matter what it is, you should be backing it up, which means this piece of sacrificial wood. And don't just hold it like that behind whatever you're drilling, because you'll eventually go through and get your finger or your hand. I wouldn't know that from experience. So for example, we'll say example about an 1/8 inch drill. We're talking about, for plastic, about 6,000 RPM, just as a guide. For normal metals, or meaning not high strength, the angle is what?
180.
Okay. 118 degrees. So we have light pressure. What do you think here?
Medium pressure.
There we go, medium. Medium pressure and medium speed. Let's see, so for an 1/8 inch drill, I'm talking about 3,000 RPM. And then for high alloy steels, for high say high alloy. We're talking high carbon steel. I should say high carbon steel, not just alloy, but be more specific, because there's different alloying agents. But so for high alloy, or say carbon,
Or chromoly or
carbon steel, steel. The included angle is 140 degrees. Lower speed. And high pressure. So about 1,500. All right, so those are the about things. About. But if you actually start reading some manuals as far as speed goes, they're going to give you a speed in SFPM rather than just a speed. So SFPM, what does that stand for? San Francisco, I don't know. Super fast. Super fast what? Parts?
super fast parts manufactured.
There you go. Sir something. With a
Permanent mess up.
surface feet per minute. And the reason why a speed might be given to you at surface feet per minute is because it is a function of both RPM and drill bit size. So this is a function of drill size and RPM. RPM stands for what? Revolutions per minute. So if we have RPM, oh, sorry, this is the formula. RPM equals surface feet per minute times diameter times pi divided by 12. So for an example, if we have that, I would say, what speed, what RPM should you use to drill a 3/8 inch hole in aluminum plate? All right, and it gives you an SFPM of 250. 250. There, 250. So the question is, what is my RPM? because that's what I can set on the machine, how fast I want to go. Now, it's going to be up to us for feed rate, how much do we push or so aluminum, we're going to push really hard, medium, or light? Okay, medium, so that we just know. So let's see, RPM equals surface feet per minute, so that'd be 250. Why does my formula suddenly look different? So I have it this way, times 12 divided by, that doesn't match that, divided by drill diameter times pi. There we go. All right, so 250 times 12 drill diameter, so that'll be 250 times 12 divided by drill diameter, which is 3/8, times pi. And I'm going to end up with 3,000 divided by 1.178. So my RPM is going to equal 2546.
Okay, so
Let's, I don't know, I've got it written this way, but it transposes around to this. So we'll just,
Oh, it's the whole thing divided by 12.
yeah, well, it's the whole thing divided by 12. Sorry, yes, absolutely.
They just copied wrong.
But I don't know. I got to be honest with you. My notes have this up here.
That comes out with like 23.
All right, but I think there was a mistake there in that one. Sorry, but anyway, this works out. I'm gonna fix that one.
is that gonna be on the test?
Well, if it is, just use this one. And if it was, I'm gonna give you the formula.
The right one or the wrong one?
I'll give you one of them, and the answer will be based on whatever I give you, right? Somebody just did the top one. It comes out way wrong, right?
Yeah.
Yeah,
So don't worry about it. We'll just scratch that one. We'll just edit that part out of the video. So.
you don't edit your video.
So here we go. Here is your formula. Just change it to this. RPM equals SFPM times 12 divided by drill diameter times pi. All right? So we'll make this the formula. And so we do that. We came up with 2,546. How does that compare with the about that I gave you a little bit ago for aluminum?
Pretty close, pretty.
There you go. Probably where I got that.
Used to figure out the amount of material you're moving per second.
What's that?
The circumference, the bottom part of that equation.
Yeah,
Is that what you're using to figure out the amount of material you're moving per second?
just looking at it, that's my assumption.
There you
Yeah, and that's why it's a function of the drill bit diameter. And we could work at a couple different drill bits, but I'm not going to make you do that. All right. Don't have a lot of time. So where am I going now? Oops, stop doing that. There are also different styles of drill bits. One of the ones I want you to know about is the modified drill bits. Modified bits for plastic and other soft materials. And one of the modifications is what's called a zero rake angle. Zero rake angle is almost a little bit difficult to explain, but I do have in lab, I made one. And it really, all you do is you take this lip, which I don't know if you can see real well, and just grind it. So right now, I've got an angle with the cutting lip, and the flute is coming back like that, right? And so right where my fingers meet, that's my cutting lip. Yeah? Okay. And my hand's got to be down here, so this angle is the what? Relief angle. Okay, then the flute comes right like that. And that's going to really cut in. And if you have plastic, that's going to cut in and actually spiral right through the plastic and then break out the backside. So a zero rake angle actually happens when you grind it square off.
So it's a 90.
And so it's like 90 degrees to that. They call it zero rake angle. I don't know why. But it becomes this squared off piece that doesn't have a lip that grabs and cuts. It's got a square piece. So what's that squared off piece going to do?
Stop this way.
Which what?
Stop this way.
shear.
It would stop it like.
Well, it scrapes. So it's just a scraper now.
I'm just gonna chip it with
There's no chips, so it just scrapes it away. So it's what you're going to see is as you do it, it's going to scrape it to a point, and then it'll actually curl up out into the flutes. So zero rake angle. Let's see, I could try and describe it. A rake angle. Rake angle is the angle made from the flute to the cutting lip. Rake angle is the angle from the flute to the cutting lip.
So what would the rake angle be on like a general purpose?
Like this one, I don't actually know what that angle is right there. I mean, it's just, there's nothing you can do to change it.
Yeah.
It's just, it's there. So it's not one of those things I worry about. I can't do anything about it.
The engineer chooses the angle, right?
Yeah. But I can change it to a zero rake angle by just grinding that away really quick. And that's what I did whenever I had to work on plexiglass of any sort. I just grab a drill bit, make a zero rake angle, and just label it plexiglass from that point on. So I had a little tray that had just plexiglass bits that I had made. I usually grab one of my buddies. Hey, can I borrow your drill bit? I don't want to use my own. Zero rake angle. Removes the sharp cutting lip. Removes the sharp cutting lip. And makes a bit. Makes a bit that scrapes. The material rather than cutting. All right, and let's see. How about a couple of rules for drilling? Well, you guys have drilled a lot of stuff already. One, always. It's like working with the computer. Always back up your work. What do I mean by that?
Something behind it.
Save as. Go ahead.
External hard drive.
Yes. So what does that mean? What do I mean by always back up your work?
Put something behind it.
Yep. Okay. What are things that should not be used to back up work?
Your hand.
Your hand,
Somebody's face.
your neighbor's laptop, your laptop.
His face.
Your wallet.
How about the desk,
A
the
vice.
table? So it's got to be something I know it's made out of wood. It does work for a while. All right.
Something sacrificial. Prince. You can back it
All
up.
right.
That's my stuff.
How? Yeah, that's rude.
James can only yell at you so long.
This is especially important with softer materials. With
That's for you to go to somebody else's room.
windshields are very expensive. They don't come pre-drilled, and they often don't come the right size. Yes, I got to get that. Got it.
You're
Right at it, too.
You're really losing it,
Why
Kevin.
don't you ream hole?
All right.
Kevin, you know they have medication for that, right?
Yeah,
Kevin,
it makes me.
why don't you ream
I think
hole
it's because I was.
Oh, let's talk about that one. Your question is, why don't they
ream holes?
ream? We do ream holes.
No, instead of drilling.
Okay, so
Like a drum.
if you and there's a lot of Q&A questions about reaming holes. So, for example, when you're drilling all of your projects, you're either using a 21, a 30, or 41 drill bit, right? And the engineers, we'll say the engineers, have figured out that's close enough, good enough, right? But when I'm working on engines, especially when I was doing cylinders, and I was working, this isn't a story, so especially working on cylinders, guide bores, guide bosses, where the dimension was absolutely critical. Like, for example, the the guide on, this is the most critical one, the guide on the light combing is 0.4995. Not 0.5, 0.4995. So we're getting out there in a dust quite a ways out, right? So 499, so 10 thousandths of an inch, 10 Geez, I'd be able to do that in my head. That's 4 digits out. So thank you, 10 thousandths. So 10 thousandths of an inch. So could I just buy a 4995 drill bit and go for it? No, it doesn't work that way. So I'm going to use a drill bit or a tool that is actually a little bit smaller than that. So you're going to get a rough size, and then I'm going to use a reamer. Now, there are different kind of reamers. The particular one I actually used a hone in place of a reamer that would actually, I could expand it and I would hone it to a final size. But there were a lot of other things where I didn't use a hone, but I used a reamer. So what I would do is it's cut to a rough size with a drill bit, and then you would actually use a reamer that is a precision tool that has cutting teeth in it that you would just put in. It's got a pilot. So the pilot would be the exact same size as the hole you just drilled, with the reamer flutes slightly bigger than that go to the size you want. And that you would just rotate through and go down. Now, the thing with the reamer is you never back up because it ruins the cutting lips. So you just ream it through, and then you get a precision hole. So that's the reaming. So if you do have a precision hole, you're going to ream. And I think there are several Q&A questions that have that. Maybe that was the IA test. I don't remember.
There's only several Q&As.
That is one day 8 plus 8.
I don't know. There's some questions I remember somewhere about reaming to size, or maybe the questions I wrote. Maybe that's what it is. So yes, you do use a reamer. Not in here. The Hylock. Yeah, I think Hylock's use a reamer, right? Yeah, it's because it's a precision size.
Were you talking about the cylinder itself or no?
Yeah, cylinder and the guide that goes in. You'll get that next class. But just engine
Not
parts.
use like a line bore?
Actually, the stuff I used was a line bore.
Oh.
It was a line bore machine, but I didn't want to get into that.
There's a question about
What?
There's a question on it.
About reamers?
Yeah.
It's like, so if you want to ream to this, what size?
Yeah, which procedure is correct when using a reamer to finish drill hole to the correct size?
So if you're using a reamer, you're always going to go undersize and ream to the final size. Okay, for larger holes, and even to some extent, I say for precision drilling, but that's kind of the way I do things. For larger holes, use a pilot hole. Use a pilot hole. All right, so what a pilot hole is, let's say I've got to drill something out this size. Do I just start with this?
No.
Okay, for a lot of reasons. One, it's going to take a lot of pressure. So a lot of drill presses don't have the horsepower to actually drill a hole that big to start with. So ideally, and as you picked up in the video, you would want a pilot hole that's the size of the chisel point. So it takes care of that and the rest of it. All right. But now here's the way I learned to drill. I started drilling material when I wasn't always a fat guy. In fact,
What?
Josh was a big guy compared to me when I was, because fit guy. But when I was started metalwork, I weighed about $150. So, and I was still this tall. So, and so we were drilling holes in iron, and I remember, my dad telling me, "All right, be careful when that drill bit catches; it'll break your arm off." I'm like, "Oh, dang, man!" I was terrified, and it wasn't quite big enough to be drilling. We were drilling holes like that big and stuff, and so the way I had to do it is I would start with a small drill bit, maybe an 1/8 inch, and I'd punch an 1/8 inch hole. Then I would go to like a 1/4 inch, and then 3/8, and then I would size it up. So in the video, the guy complained about that because he said, "Well, it tears up the corner of the drill bit." Okay, true.
Rather than tear your arm.
I know, but
Huh?
yeah, break your wrist or something. So yeah, yeah, it's really funny. And I've got the wrists of a 12-year-old girl. So nothing
You were
usually
going
wrong.
around with the drill.
I know. I've been around. You had this giant.
Helicopter.
I know. And of course, yes, I didn't get one of these little tiny pneumatic ones. I got this half-inch electric thing.
my God.
You know, just plug it in where the dryer goes. It'll work. You know, so I had a lot of- So anyway, I've always been that way. That's the way I learned. I use a pilot hole. I size up to what I want to do. Yeah, I can tear up a drill bit as we saw, but hey, that's the way I do it because I'm more interested in my final product and not breaking my wrist than what's going to happen to that drill bit. And that's especially true if you use hole saws. So I don't think you guys have used a hole saw, but it's a circle that's saw teeth. And those things really tend to catch an edge. When you guys use knockout plugs, I think, right?
Yeah.
Okay, and step drills? Yeah. Step, huh?
Those will catch if the metal's sticking up.
Well, I've only used step drills on. They're pretty expensive, so I use it on thin stuff. So, but you guys got to use it. All right, so use a pilot hole. I love pilot holes. In fact, I even think I wrote the directions for your rivet gauge. Not that you guys use it apparently, but I had you drill a pilot hole even in stats something that small.
I used it.
Huh?
So you must still be talking about Christian.
No, talking about a lot of people right now.
I use mine all the time.
Do not hold material with your insert body part here. I'm going to put hand. One of the guys I work with had his finger sewed back on. You know what an Adele clamp is? Yeah. Cushion clamps. So it's a clamp. I don't have to Google a picture. It's a clamp that comes around.
Is this considered a story?
Nope. It's learning. And there's a hole here, and a hole here. And this particular size had a 3/8 hole. Whatever it was. He needed it bigger. It doesn't matter what size hole it was. 3/16. I think he needed to go to 1/4 inch. And so he put the drill bit in the, and it's very thin metal. It's very thin, but it is steel, most of them. And so he just put the drill bit in the drill press, and he put his finger right through that loop like he's wearing a nice little ring. And he just kind of went up the drill. And because it's that thin metal, it just grabbed it and tore the metal and made a bunch of sharp shards and just ripped his finger kind of right off. So, yeah, don't do that.
I would just take
I
safety
bet his
wire
wife is
pliers
happy.
and crimp the clamp in there, and blow the hole out.
Do what?
Take safety wire pliers.
Yeah. Oh, yeah. And hold it.
Down and just hope for.
I know,
and
but
drill it out. Just in that.
yeah, wear safety glasses.
That sounds
You
crazy.
couldn't find it.
Don't put them on your hair.
All right.
You have 9 other ones anyway.
I think that's all I need to say about drill bits, which is actually quite a bit. I mean, that's a day and a half worth of talking about drill bits.
Yeah, who would have known?
Who would have thunk it, right?
Dang bitches.
All right, let me just. Oops. Okay, so given this, which actually you can't. Oops. Wow, that just got all messed up.
Still want you to print one out.
Huh?
Still want you to print one out.
It's on canvas.
That's in your
It's on
text.
canvas. Yeah.
Oh, this isn't gonna work because it's covered up on the bottom of the screen right there. So I gotta go like that. All right. So no, is this on canvas? It's in your textbook. I know you have it. It's that thing that's still wrapped in clear plastic cellophane so it won't get dirty. You have to pop it open and
It's not big enough.
okay.
Okay, boom.
I had this open today, Kevin.
Yeah, did you? Oh yeah.
Swear to God, it was like a 9.
You don't have to say. Okay. What is this right here? What does this represent?
Oh, that is shank.
Shank. Okay. What is this part here?
Body.
What is this pointing at?
Flute? Land.
Inside.
I know how Steve feels.
Oh,
There
there
it is.
Hey!
There we go. That's a land. Land hoe.
Land. Okay. What is this pointing at? What are we looking at here?
Margin?
Probably the margin. I don't think they're pointing to the center line, so I'm going to say it's margin probably. Okay, so what is this angle right here?
The cutting.
That line doesn't exactly line up with this very well, does it?
Include that. Isn't that the cutting angle?
It does tend to line. Is it lining up with the flute? Yeah, it sort of lines up with the flute. They should have put it here.
Yeah.
All right, so if this line matches that line, we'll call it the flute. Ah, what is this one here?
Keel angle?
This is a chisel edging.
Chisel edging? Oh, this is a stupid one here because that's that,
That's the chisel edging.
yeah, the lip angle.
The heel.
Wait.
Kevin, one of the ones I was looking at, it said you have
For her, it says heel.
a neck. It's like before. Do you count that at all?
The
Like
neck?
shape,
No,
the
no, I
neck
don't.
and the body?
All right, well, that actually is a little confusing, so let's go to this one. What do we got here?
Getting.
Well, it's like
Okay, that doesn't line up with that, but I'm going to call it
The lip angle.
Well, they called it the lip-
Cutting edge.
That's why.
lip angle. They just made that line a little pathetically off here. That's pointing to the lip or cutting edges. Oh, I see. It's not an angle. It's pointing to the I don't even understand what they're doing. Okay, so go back here. So this angle right here is the all right lip angle, or also called the
Cutting edges.
Included.
not the
Lip or
included.
cutting edges. The heel.
Oh, wait a minute. I'm sorry.
Was it a half?
Lip angle, yes, or also called the
Cutting edge.
no,
chisel.
no, lip angle, or I've been calling it something else. It's 59 degrees times 2,
Included.
118.
Included angle.
The included angle.
Included angle.
That's still it's off. So this is the what?
Lip angle?
Included angle.
Included.
All right. This one is the
Land.
land. Okay. This is flute.
Body.
Body. All right.
You don't have mark.
They're what are they trying to represent here? I don't like this one, but
Keel angle?
relief angle.
Early?
Yeah. Heel angle or relief angle is what I call it. Chisel edge angle. That's what that is. That's not the lip clearance at all. That's a chisel angle. All right. So lip angle, normally 59, also called the
Included.
included angle. All right. So you think you can handle that?
Where's the chisel edge angle actually measured from?
Yeah, it's just like.
It's just
Yeah.
from
A
the
line
the
that this
middle,
makes versus this here. So that and that.
But that line is
But
not
the
like
other
that.
line.
That's why I don't. Yeah, neither is this line. Is it?
Yeah, but
So. All right. As the drill bit gets shorter, the chisel point does what?
Gets wider.
Why does it get wider? Oops. You can't see that if you're actually watching the video.
Well, sucks to be them, doesn't it?
I know.
Has to be Christian.
Sorry, Christian. You're lost.
should have been.
Where is Christian?
I don't know.
Obviously. It was all- if I-
There you go. Now you can see it. Except that didn't. Now that didn't. I'll see, Christian, you screwed everything up for me. All right.
What an asshole.
Whatever. Okay. Let's see. Drill bit gets shorter. The chisel point does what? Wider. Why?
It's all safety.
Because of the web.
Because the web gets thicker. All right. If I am drilling, as the material I'm drilling gets harder, what am I going to want to do with this included angle?
Make it flatter.
Are we reviewing for the test right now?
120 degrees.
Reviewing material.
Sorry.
Reviewing material.
But I was missing something here.
Larger number.
It gets flatter,
But it goes higher.
but the angle gets higher.
Yeah.
That's why I'm very careful every time I talk about it. I say it gets more pointy or flatter, and then I give you a number. So softer material, it's going to get more pointy or 90 degrees. All right, higher strength stuff, it's going to get flatter or closer to 180. So, all right.
So that degrees is wrong, right?
Huh?
That degrees.
Lip clearance?
Yeah.
No, that's not. It's actually the chisel angle right here.
Oh, okay.
Okay. All right, we have two questions. Yes.
You said go ahead. You said the other day there's the one at 90 degrees and there's an even pointier one at 40 degrees.
No, I didn't say that.
No.
That's a hell of a.
No, you confuse pointy with 40.
90, half of 90 is 45, so I don't know, 45 on each side.
So I was looking at the Q&A.
Hush!
I was looking at the Q&A and it said what should be the included angle of a twist drill for hard metal.
Okay?
The options are 118, 90, and 140.
Yep. Okay, let's go with this.
Not 140, 100.
Okay, but it's asking about what kind of metal?
Hard.
Hard. Okay, so hard metal. And this is the thing. This is a perfect example of this is Q&A stuff. Hard like mild steel. Because if I get hit by a piece of mild steel, I go, that's pretty hard. Or hard as compared to mild steel, carbon steel. That's why you have to know the Q&As. So just based on that, I would say, okay, 118 is normal stuff, aluminum, mild steel. What's my other choice? 90. I would say that's clearly plastic. I wanted 140, but they don't give me that. They give me 100. So wait, 100 is closer to 90. So is that more pointy? So you have 118, 100, 90. What would you pick? I go 118, and that's the flattest stuff they give you.
Okay, so it's just an interpretation.
What's the answer on that one?
118.
118, because it's the flattest option they gave you.
Okay.
In the explanation, it says something about aluminum too.
Okay.
Hard metal.
So again, the harder the material, the flatter we want it, which is also called a higher angle, even though it goes against what we're thinking.
What's the higher angle?
It's an obtuse angle.
Well, higher is actually 180, so it's flat. It's a higher number versus 90.
Is that going to be on the test, Kevin? The more flatter?
Absolutely.
Yep,
Or,
absolutely.
That's one of the answers.
There's like 6 of them on there, just like that. My relief angle. What happens if the relief angle gets too low?
More heat,
Looking for a nice relief angle picture here. Don't know if I have one. What happens if the relief angle is?
More flatter.
There we go. Yeah, it's more flat.
It'll get hot, burn its way through.
burn.
Okay. What if it's too much?
Oh, very little.
Okay, edge chips.
Yes.
What's the proper way to measure a drill bit? What's the proper way to figure out what size this is?
Was it stamping?
From margin to margin.
What's that, Brett?
The stamping?
Look at the stamping on the side. It says 1 1/8.
Nice.
Okay, if I can't see that, where do I measure? Well, normally the shank is the exact same size, so I measure down at the shank.
Biggest part of the shank, because that one's the taper.
Yes, yeah. Well, because it's a taper shank, I would measure nowhere near the shank, nor would I measure this little step. It's got to be right here. So, given a normal drill bit, would I measure the distance between the lands?
Yeah, land. But margin from margin. From
I
margin.
said land. Land? Yes or no?
Yeah.
Yeah.
I'd say so.
The land is the reliefed out part.
Oh no, the margin.
Margin sticks out.
Yeah.
Okay.
From margin.
Margin to margin?
Yeah.
Well, that's going to be kind of hard on something that's round like that. I don't know. How about measure the shank? I'm going to go measure the shank. I would say that's the proper way to do it.
Okay. So what is it
Okay.
measuring?
Huh?
I thought in there they called you measure.
There was one drill bit they talked about that was relief down. So that wouldn't work. So, but generally speaking, you always measure the shank.
Well, the margin will actually meet up with the actual diameter of the bit itself?
It does, yes. Yeah, if you look at this one, you can see the margin measures out to right here exactly. So it's the exact same size as this. So rather than trying to get a micrometer margin to margin, just come down here where it's all, you can see where the relief stops. And so down here. So it would be measured at the shank, unless it's a taper shank. Don't measure taper shank. Got it? When drilling soft material, pressure, high or low? Included angle, high or low? Okay.
Low. So material low angle.
More pointy, low angle. Thank you.
Yeah.
Lower number. If I have a drill bit with a 0 rake angle, what am I probably drilling?
Plexiglass.
Okay. What would be the proper size pilot hole?
Size of the chisel.
Size of the chisel or slightly larger?
Slightly larger.
Okay. All right. Yes. I'll be the judge of that.
If the flutes are round, was the drill bit used to make the drill bit?
If the flutes are round,
Yeah, was it,
was it a drill bit used to make a drill
how
bit?
did you make the drill bit?
Huh?
How was the drill bit made?
I don't know. I'm not a drill bit manufacturer. I don't even understand the question. You're right, it was a stupid question. I don't know. Just kidding. It's not. I just don't. All right. Okay, so I guess that would be a good time for a break, and then we can address this important question.